Okay, so we've still got our template. We've got, for implicit differentiation, we've got a quite complicated equation here that is the equation of a curve, and we've got x's and y's all mixed up over here, and they are connected by multipliers, so we're going to definitely be using product rule with both those two terms. So we throw our template over this situation where we've got to find dy dx. So our first step is to find with respect to x over each term. So we go d dx of x cubed y cubed plus d dx of x squared y equals d dx of 12 minus d dx of 2x. So that was our first step. And then we've got to evaluate each of these. If we look at the first one, this is my u and this is my v, and we're going to use the product rule to find the derivative with respect to x. So it'll be u v dash. So u is equal to x cubed v dash. Now we're going to find the derivative of this. We've got the chain rule going on, so we've got to find the derivative of y, which is 3y squared, and then do dy dx. So that's u v dash plus u dash, that's easy because that's just 3x squared v y cubed. So that's the derivative, this here is the derivative of x cubed y cubed. We've used the product rule and we've got u v dash plus u dash and v. Alright, if we go over here, this will be my u and this will be my v, and so we've got plus, it'll be u, which is x squared, v dash is just dy dx, plus u dash, which is 2x, and v is y. So those two terms are the derivative with respect to x of x squared y equals d dx, derivative with respect to x of 12, constant, 0, minus derivative with respect to x of 2x, this is simply 2. Alright, that's the first step. Now, the second step is to get all the terms with dy dx on the left hand side. Okay, we need to identify which terms have got dy dx. We've got this one here and we've got that one there. So we're going to get all those on the left hand side. So we got, maybe we'll just write this a little bit better. We'll put the 3 at the front. So we've got 3x cubed y squared dy dx. So that's that term, plus x squared dy dx. It doesn't matter if dy dx is at the front or at the back. Equals negative 2, stays where it is. This comes over, so it's negative 3x squared y cubed. And this term here comes over, so negative 2xy. 3 is to get dy dx out the front, and so we've got dy dx is a factor of both those two terms of 3x cubed y squared plus x squared equals negative 2 minus 3x squared y cubed minus 2xy, and last but no means least, we divide right through by whatever is in that bracket which is there to get dy dx by itself. Minus 2 minus 3x squared y cubed minus 2xy all over what's in the bracket there, 3x cubed y squared plus x squared. So there's my dy dx. Okay, so that's find the gradient of the curve at that. So we've found a rule or a formula for what dy dx, which is the gradient at any point xy on the curve. X equals 1, but hold on a tick, we've got x's and y over here, so we need to find some y values, a y value, and a particular y value when x equals 1. What do we do there? We actually put x equals 1 in the original equation to find out what y is. So we've got x equals 1, so we've got 1 cubed y cubed plus 1 squared y equals 12 minus 2, and from that we've got y cubed plus y equals 10, and from that we can work out that y would have to be equal to, y is equal to 2, you get 2 cubed is 8, plus 2 is equal to 10, so y is equal to 2. And so we know that 1, 2 is the point that we want to find the gradient for, so we can substitute that into dy dx, and we get dy dx is equal to minus 2 minus 3 times, now 1 squared, so we're substituting in up here, and we're putting x equals 1 and y equals 2 up here, so it would be 3, 1 squared, 2 cubed, minus 2 times 1 times 2, all over 3 times 1 cubed, 2 squared, plus 1 squared. And we get negative 2, that's 8 minus 24, and that's minus 4, all over 4, 12 plus 1, and that's equal to, what's that, negative 26, negative 30 on 13. So that is the gradient at the point 1, 2 on the curve x cubed y cubed plus x squared y minus 12 minus 2x. So the steps, the template steps for finding the implicit differentiation still hold true, and we just followed those. A little bit more difficult with the two product rules there, but we still applied them. We got dy dx, we were only given the x value, so then we had to go and substitute in that x value in the original equation to get what the y value was, and we found the y value, then we substituted that x value and that y value in dy dx to find out what the gradient was.